In this tutorial, I'll show you how to integrate using inverse trigonometric substitution. This is question 5. The function that we'll be integrating in this video is the following, where we are asked to integrate d of x over x squared times the square root of 1 plus x to the power of 2 between 1 over the square root of 3 to 1. To do this, we'll need to match our function to one of these expressions. And you'll notice that our function matches this one, the square root of a to the power of 2 plus x squared. And in our particular case, a will equal to 1, and so we'll set x equal to 1 times tangent theta, or simply x is equal to tangent theta. The next step is to find the derivative of this equation, and if we do that, we end up with dx is equal to secant squared theta d theta. The derivative of tangent theta is secant squared theta. Now what I have to do is find new lower and upper limits, because we've changed our original function to one that is in terms of tangent theta. To do this, I'll take tangent inverse of x. Tangent inverse of x is equal to theta, and I'll substitute my lower and upper limit into the x one by one. Starting with my lower limit, when x is equal to 1 over the square root of 3, we'll substitute this into x, but instead of using our calculator, we can use special triangles. And the special right triangle that I'm thinking of is this one in particular, pi over 6, pi over 3. And so if I substitute this into here, the angle that will give me this particular ratio, remember tangent is opposite over adjacent, opposite is 1, and the adjacent is the square root of 3. Therefore, our new lower limit will be pi over 6. And I'll do the exact same thing for 1. If x is equal to 1, we have to use the other special triangle, the pi over 4, and pi over 2 triangle, which looks like this. And so when x is equal to 1, and if we replace this 1 here, we end up with theta of pi over 4. So I'll rewrite my brand new function in terms of theta and these new lower and upper limits, pi over 4 and pi over 6, and my dx now will be replaced with this, secant squared theta d theta over, this has become tangent squared theta 1 plus tangent squared theta. What I'll do next is replace 1 plus tangent squared theta with the following, right here, secant squared theta. So I'll replace this part, the radicand of this radical, with secant squared theta. And of course, the square root of a squared term loses the square root and the square. So we're left with this expression, which can further be reduced into the following. Once you've reached this stage, you need to further simplify. Remember that tangent on its own can be simplified into sine theta over cosine theta. And if it was tan squared theta, this would be squared, and so would this. Now, since tangent is at the bottom, we can separate this where we have 1 over tangent squared theta, and we have 1 over this expression. So this ends up becoming the reciprocal of this, pi over 4, pi over 6. This also can be turned into 1 over cosine theta. And like I said earlier, the reciprocal of this is cosine squared theta over sine squared theta d theta. This cancels out with one of these, and we're left with the following function. Now, to find the integral of this, we need to use u-substitution. U-substitution. Now, there are other ways to doing this, of course, but u-substitution works, and I will set my u as sine theta. If I set my u as sine theta, I take the derivative, du is equal to cosine theta d theta. And since I'm setting my u equal to sine theta, I now have to change my lower and upper limits again. And as such, I'll start with the lower limit. When theta is equal to pi over 6, and remember, solving for theta here, we end up with sine inverse of u is equal to theta. So when theta is pi over 6, what will our u become? Once again, these are the special triangles. I'm going to do them really quickly for you. So if we take sine at this angle right here as our reference, opposite over hypotenuse is 1 over 2. So our new lower limit will be 1 over 2. And when theta is equal to pi over 4, and we take the other right triangle into consideration, any one of these will work. Opposite over hypotenuse is 1 over the square root of 2. So these two represent our lower and upper limit. So let's rewrite that. This was our lower limit, and this is our upper limit. And we're left with cosine theta over u to the power of 2. D theta is equal to du over cosine theta. All I did was manipulate this to solve for d theta. This cosine and this cosine will cancel out, and we're left with a fairly simple function to integrate. We have, I'll manipulate this up here. This is the same thing as saying u to the power of negative 2. And the integral of this, you add 1 to here, and if you add 1 to that, you end up with negative 1. And that negative 1 goes down here. This ends up becoming negative 1 over u. And you don't need to add the plus c, because remember, this is a definite integral, so we'll need to evaluate this at the lower and upper limit. So starting at the upper limit, negative 1 over the square root of 2 minus the lower limit now, negative 1 over 2. Simplifying this, we end up with negative the square root of 2 plus 2. And this right here represents the answer to this question. And there you have it. That is how to integrate using inverse trigonometric substitution.